Good day, everyone. We're still in physical science and we'll be talking about the interaction of waves. Okay, so this would be, although ang dami-dami pang pwedeng pag-usapan about waves, especially electromagnetic waves. Kaya lang, syempre, doon lang muna tayo sa very, very basic concepts. Okay, so we're done with mechanical waves, electromagnetic waves, and then let's take a look at how these waves interact. Okay? Yan, ano ba yung interaction nila? Alright. Let's take a look at them. So, ano ba yung mga interactions of waves? So, we have reflection, refraction, diffraction, and then interference. Okay? So, now let's take a look at them one by one. Okay? Starting with reflection. So, reflection is the bouncing back of a wave after it strikes a boundary or comes to an end of the medium it is traveling in that does not absorb all the wave's energy. So, ibig sabihin, if it's a mechanical wave and it reaches the end of the medium, and the medium can no longer absorb the wave's energy, then that wave would bounce back. Okay? It will bounce back. Okay? Ayan, ganun yun. Alright? Or if it is an electromagnetic wave and it reaches a boundary, wala nang di ba? Then it would bounce back also. Okay? As a reflection. Right? So, here, this is a diagram that will give us or that will show a wave activity. Okay, so here we draw, a line is drawn in the direction of motion and you call that a ray. Okay, so here that's the direction of motion. Yan yon. Okay, the motion of the wave. Okay, so we just illustrate that as a ray. Okay, para mas madali although they are moving as a wave. Okay, and this part here would be the boundary, okay, the boundary or the end of the medium, if that would be a mechanical wave. And then perpendicular to that, we draw an imaginary line, okay, that is perpendicular, okay, to that. All right, so yan yon. So how do we see that? How do we observe yung part na yan? So you have something that looks like this. Ayan. So here is a light wave that when it strikes a boundary, it would be reflected. Okay, yan. It would bounce back. Okay, in a different direction. But makita nyo dito that the incoming wave, yan. So describe muna natin yung mga rays na yan. So the incoming wave is called an incident wave. Ito yon, okay? And then the wave that bounces back, we call that the reflected ray, okay? Or the reflected wave, okay? So yan yon, okay? So this is the incident light and that is the reflected light, okay? Now the angle formed, yan, ito yon, this angle here, by the incident ray and the imaginary line, which is perpendicular to the boundary, we call it normal, ano, the angle that the incident ray forms with the normal is called the angle of incidence. And then the angle formed by the same perpendicular line and the reflected ray, we call it the angle of reflection. Okay? Ayan. So, yun. Those are the various description of wave activity. Okay, so according to the law of reflection, the angle of incidence is equal to the angle of reflection. And that would mean that the angle the incident wave makes with the surface is equal to the angle the reflected wave makes with the same surface. So it has to be the same surface for the two angles to be the same. Okay? So ano ba yung implication ng mga angles na yan? Bakit ko ba in-introduce yan? Yan. Kasi it finds, marami pa kasi yan eh, may mga iba-iba pang mine-measure dyan, alright? But they find applications in mirrors, in lenses, mga ganyan, sa mga reflection na yan. Now, speaking of reflection, there are actually two kinds of reflection, okay? The type of reflection depends on the surface that that the light strikes. Okay? So, kaya sabi dito, the type of surface the light strikes determines the kind of reflection that will be formed. And there are two kinds. Okay? So, una muna, we have the regular reflection. So, itong regular reflection, it is if the reflecting surface is a very smooth surface, yan. So the reflection will be a regular reflection. Yan. The light rays maintain their position. So kung paano siya, kung ano yung position niya nung pumasok yan, as incident ray, has the same angle as that of the reflected ray, okay, with respect to the normal, okay? So, regular reflection yon, okay? Now, the other type, we have diffuse reflection. Here, if the reflecting surface is rough, the reflection will be a diffuse reflection, okay? And then objects will not be visible or identifiable in the reflection, right? But sometimes, class, we think of certain surfaces na mukhang smooth, pero walang reflection, walang identifiable uh, objects in the reflection. Why? Kasi in the scale of the wavelength, hindi talaga sila smooth, but they are actually rough. Okay? Yan, kasi sa scale ng wavelength, ang liit nun, di ba? From, it's as small as the nanometer scale, ganyan, and then to the negative 12. Yan, so yung scale. So, then, you won't see any identifiable objects in the reflections. Okay, so these are the illustrations of the regular and the diffuse reflection. Okay, ayan. Okay, so here, that's it. And this is the one that is diffuse kasi rough yung surface. Di ba parang pag nagdi-dribble ka ng bola, pag sa basketball court, makinis kasi doon, di ba? Tapos, pag nag-dribble ka, you would be able to predict saan magbabounce yung bola. So, madali mong masalo, di ba? Whereas, if the surface is rough, okay, then it could go in any direction. O, kaya mahirap i-predict kung saan magbabounce back yung bola. Okay, so the same is true with light, okay, with respect to the surface. Okay, all right, so yun. So now let's move on to refraction. Okay, so refraction naman is the bending of waves due to a change in speed. Okay, so dito, ang nag-change basically is the medium. Okay, the medium. Sabi natin, di ba, at a particular medium, the wave velocity is constant. Okay, so if you want to change the velocity of the wave, then you change the medium. Kaya nag-change yung speed kasi because of changing mediums. Just like, for example, when light passes through air, and then all of a sudden, it's going to pass through water, di ba? So, doon nagkakaroon ng refraction. Okay, so, I mentioned light. So, they still can pass through a medium, but they can travel even without a medium. Okay? Yan, all right. So, we call that refraction. Yan. So, the waves bend kasi nag-change ng speed. All right? As they travel from one medium to another. Okay? Yan. So, yung change ng medium na yan would cause not only a change in speed, but also a change in the direction. Okay? Yan. Kagaya nung sinabi ko kanina, in air, okay, you would expect in terms of ray. Okay? So, ito yung itsura niya. Yan. So, that would be the ray. And that one is traveling in air. Tapos biglang may naging tubig. It passes through. Okay? Through the water, magkakaroon ng bending of the waves. Alright? So, yan ang refraction. Alright? So, this is how we experience it. Yan. So, that's what we observe. Diba? Nagkaroon ng bending. That is refraction. Okay? So, the next time around that you see a similar situation like this, then you can think of refraction. Okay? All right, now next. All right, so the amount of bending depends on two things. O, nabanggit ko naman na yun. Yung una, we have the speed. Diba? It could slow down or it could go faster depending on the medium that it passes through. Okay? And the angle of the incident ray. Okay? So, with respect to the normal, yun yung sinasabi nating angle of incident ray. Okay? Siyempre, the greater the angle it enters a substance, then that would determine the noticeability of the uh, refraction or the bend of the ray. Okay? Pero kung it's almost straight on o halos 90 degrees, okay? So halos wala nang change sa direction. What changes would be just the wave velocity. Okay? Yan. Alright. So next we have diffraction. Okay. So sa diffraction naman, it is bending of waves also. Kaya lang, okay? It occurs kasi sa refraction, okay? The wave can pass through the medium, okay? Kaya, but because it's a different medium, mag-change kaunti ng direction, but it would pass through also. But in diffraction, there is an obstacle, okay? Kaya the bending is because of yung parang going around the edge of the obstacle, and as a result, it would give a new series of waves. Okay, or a new series of waves are being formed. Okay, when the original waves strike the obstacle. So para bang isang single, di ba? Tapos pag may nadaan ng obstacle, magi-spread siya. So in other words, this diffraction is also spreading out of waves as they pass through an obstacle or through an aperture or around objects, right? So, ayan. So, depende yung diffraction niya depends on the size of the aperture and the magnitude of the wavelength. Okay? So, it's one that looks like this. O, ayan. Okay? So, na-spread kasi dumaan dun sa aperture doon. Okay? So, in our experience, okay, we experience it this way. Yan. Okay? So, that's an example of light that is diffracted. Okay? Obstacle yung tree, okay? So the trees serve as obstacles, so the light rays are spread out, okay? And then it looks like the single wave coming from the ray, the incident ray, would be spread into waves, series of waves. Okay, so yan yon, all right? So that's it. And then the last interaction on our list is the interference. Okay? So this is an interaction that occurs when two or more waves arrive at the same place at the same time. Okay, so ano nangyayari when there's interference? Okay? Kasi two or more waves arriving at the same place, the same time. Okay? Yan. So this is actually the combining. Okay, so if there are two waves, then as they combine, it becomes one. Okay, or if there are three waves, they combine and it becomes a single wave. And with this, there are two types of interference. Okay, so ano yun? First one, we have the constructive interference. Alright? So here, nagkakaroon ng constructive interference if, okay, troughs meet up with troughs or crests meet up with crests when they arrive at a certain point at the same time. So, ang nangyayari, yung amplitude ng isang wave adds up to the amplitude of the other wave when they become one wave. Okay? O kaya yung resulting wave, as they combine, would be having a higher amplitude than any of the original waves. Okay? So it looks, ayan. So crest to crest, wave to wave, throw to throw, they're the ones that meet up. Okay? So it looks like this. So ayan. Alright? So here, throw meets up with the throw. The crest meets up with the crest when they arrive at the same place at the same time. Okay? So parang the resulting amplitude is just the sum of the amplitudes of the individual waves. Okay, so anong implication yan? It would result to a wave that carries with it a higher energy. Kasi higher yung amplitude, di ba? And it could mean two things. It could be beneficial or it could be harmful. Depende kung saan galing o kung saan yung waves na yon. Okay? And you will be seeing the connections a little later on. Okay? Mamaya, you will see kung ano yung connection. Alright? Now, next, the other type is the destructive interference. So, dito naman, when the waves combine and then the disturbance or yung resulting wave, okay, results in a wave that has lower amplitude than any of the individual original waves. Ang nangyari kasi dyan, it is the trough that met up with the crest, okay, yan. When they arrive at the same time, at the same point or at the same place. Kaya, anong nangyari doon? The amplitudes, you get the difference. At yun yung amplitude ng resulting wave or the resulting disturbance. So here, the crest and trough combine by subtracting from each other. Okay? So to form a single wave. Ayan. So yung amplitude nila, isa-subtract mo. Okay? At kung ano yung difference, that would be the resulting amplitude of the resulting single wave. Okay? So again, alright, ayan. So, it looks like this. Okay, so, bakit walang resulting wave? Okay, if this is the one that happens, if this happens, that means the amplitudes of the two waves are equal. So, equal lang yung amplitudes nila. So, for example, if the amplitude of this wave is 2 nanometer, o kung ano mang measurement, I don't know, or 8 nanometer, and this one is 8 nanometer also, 8 minus 8 is 0. So parang they canceled out each other if they have the same amplitude, okay? Now, what results to a resulting wave is if one of the waves, okay, has higher amplitude than the other one. So, isusubtract lang. So, yun yung result. So, nalilesen ngayon yung energy that it carries with it. Okay? O, kasi yung mas mahinang wave would be canceled out by the stronger wave. Okay? So, something like that. Okay? So, that's it for our wave or interaction of waves. Okay? So, next now, let's take a look at some connections as I have said earlier. So, I'm going to read to you a narrative. I'm going to narrate something to you that gives connection. So, ito mga ito, these are the things that really are happening around us, maybe, or things that we observe that are happening, okay, and that are based, okay, on the concepts na mga diniscuss natin before. So first, we take a look at, ito yung title nung unang babasahin ko sa inyo, Shake, Rattle, and Roll, okay? So this describes connections for mechanical waves, okay? So listen carefully as I read to you this one, okay? So shake, rattle, and roll. About 1 million times a year, some part of the Earth's surface shakes and trembles in a violent release of energy. Such an event is called an earthquake. An earthquake occurs when energy stored in the Earth's crust builds up to the extent that it causes different sections of rock to move. From the point at which the earthquake originates, waves ripple out in all directions. Earthquake waves are known as seismic waves. There are three different types of seismic waves. Those that travel the fastest are called primary waves, or P waves, because they are recorded first. P waves are longitudinal waves. They move through solids, liquids, and gases. The next type of seismic wave is a secondary wave, or S wave. S waves are recorded after P waves. S waves are transverse waves that move through solids but not through liquids and gases. The last type of seismic wave is surface wave, or L wave. When P waves and S waves reach the surface, they are converted into L waves. L waves travel along the Earth's surface, causing the ground to move up and down. L waves cause the most damage because they are responsible for bending and twisting the Earth's surface. Scientists have learned a great deal about earthquakes by studying seismic waves. By using an instrument called a seismograph, which records seismic waves, scientists can determine the presence and strength of an earthquake. The greater the amplitude of the seismic waves, the greater the amount of energy they carry, and therefore will have the greater or more powerful earthquake as a result. Okay? So studying earthquake wave activity has enabled scientists to gain insight into predicting and describing earthquakes and also to think about preventing them someday. Okay, so that's all about. Alright, mechanical wave connections. So, nakita natin yung connection sa earthquake do sa ating mga pinag-aralan about mechanical waves. Okay? O kaya siguro yung part na sabi when S wave and P waves reach the earth, probably they arrive there at the same time. Kaya yun, nagkakaroon ng interaction o kaya yun, they combine. Okay? So sana lang ano, yung waves crest to throw yung meet up para malesen. Eh paano kung throw to throw, crest to crest, okay? Kaya nagiging stronger, okay? So siguro lang ano naisip ko lang ito siguro yung mga time na nagkakaroon pa ng mga aftershocks, okay? Kasi may mga lindol na mahina lang, maybe, okay? Yan. All right. So that's all about mechanical waves, okay? So now let's take a look at electromagnetic waves naman, okay? And the title ng ating narration this time, we call it The World at Your Fingertips, okay? So listen again. The world at your fingertips. Click, the television goes on. Click again and the volume goes up. Click once more and the channel changes. Remote control or controlling a device from a distance has become a standard feature of many household products, ranging from television sets to garage door openers. Beyond the household, remote control is used to control faraway devices such as satellites and guided missiles. Remote control makes many devices easier to operate with just the push of a button. It also helps to perform tasks that would otherwise be difficult, dangerous, or even impossible. There are different kinds of remote control mechanisms. Consider the television again. When you push a button on the remote control, you set a tiny device into vibration. The vibration produces an infrared beam carrying a signal that is sent to the television. The signal depends on the button you push. A detector on the television receives the infrared beam signal and converts it to an electronic signal. The electronic signal controls several switches, like for example, the on and off switch, channel selector, and volume. The switch that is activated by the electronic signal depends on which button you press. Infrared waves are also used to carry signals to VCRs and cable television boxes. Other remote controls use radio waves. For example, radio waves are used to drive toy cars, fly model airplanes, and open garage doors. A remote control device sends radio waves carrying signals to the object. A receiver decodes the signal and passes on the message to tiny motors controlling the object's movements. Some radio control systems work with the aid of computers. Controllers on the ground use the combination of radio signals and computers to position antennas and operate other equipment on artificial satellites in orbit. So the next time you effortlessly push a remote control button, think about the electromagnetic energy involved. From toy cars to guided missiles, electromagnetic waves, okay, really do put the world at your fingertips. Okay, so that's it. All right, so that ends our discussion about waves and their connections, right? So with that, I hope you were able to appreciate yung lahat ng mga concepts pinag-usapan natin. Yan. And the next time you observe around you, then you can be able, hopefully, to connect to sa mga concepts na diniscuss natin. Okay?